Solve radical equations. In our first example, the first thing we have to do is add 3 to both sides to get this radical isolated. We have 2x plus 3 equals now the square root of 28x plus 29. Now we can square both sides and the radical is gone. On the left hand side we have 4x squared plus 12x plus 9, and that's equal to 28x plus 29. Now we have to solve this quadratic, so we'll get one side to be 0. Let's minus 28x. We have 4x squared plus, actually it's going to be minus 16x, and then when we minus 29 we get minus 20 equals 0. We can factor out a 4. We get x squared minus 4x minus 5, and that's equal to 0. And then we can factor the quadratic. We have x minus 5 and x plus 1. So x is equal to 5 or x is equal to negative 1. Now when we square both sides of an equation, some funny things can happen, so we have to check our answers. It's not really an option when we have a radical equation. Think about, for example, let's put this in a different color because it's really kind of, kind of an aside that we have. Off to the side here, if we had negative 2 equals 2, that's clearly not a true statement, that's false. But if we were to square both sides of the equation, we'd have 4 equals 4, and now that's a true statement. So what was originally false could be made true by squaring both sides of the equation. So right here, if we plug a value in that would make this false, by squaring it, it could possibly make it a true statement. So let's plug in the first one. Let's plug in 5. And we're plugging this all the way back into the original equation. We have 2 times 5, which is 10 of course, is equal to the square root of, 5 times 28, that's 40, 10, 14, 140, plus 29, and then minus 3. We have 10 is equal to the square root of 169 minus 3, so 10 equals 13 minus 3, 10 is equal to 10. 5 is a good answer. Let's test negative 1. We have 2 times negative 1 is equal to the square root of 28 times negative 1 plus 29 minus 3. We have negative 2 is equal to negative 28 plus 29 is 1. So negative 2 is equal to 1 minus 3, which is equal to negative 2. So negative 1 is also a good answer. Solve radical equations. Here we have another one. Let's get the radical by itself by subtracting 8. We have 4 is equal to the third root of x minus 2 squared. To get rid of the radical, we have to take both sides to the third power. We have 64 is equal to x minus 2 squared. Let's FOIL out the right side. We have 64 is equal to x squared minus 4x plus 4, and then minus 64 over. We have 0 is equal to x squared minus 4x minus 60. Now we need factors of 60 that add to negative 4. How about x minus 10 and x plus 6? We'd have negative 10 and positive 6, that's negative 4. X equals 10, or x equals negative 6. Now when we raise both sides to the third power, that's not the same as raising to an even power, so both of these answers should be good. Solve radical equations. In this particular case, we cannot isolate either one of these radicals. So as it sits, we just have to square both sides, and we'll deal with it. On the left-hand side, we have x plus 1. And on the right side, if we were to square this by multiplying by another one, which is really what squaring is, then we can FOIL. And hopefully by writing it out like this, you can see the FOIL a little better. So first would be 1 times 1, that's 1. Outside would be 1 times the radical. Inside would be 1 times the radical. So now there's 2 of them. So we have 2 times the square root of 2x minus 12. And then last, when you square the radical goes away. We have plus 2x minus 12. Well, now let's get everything to the left-hand side with the exception of the radical. We have 1 minus 12 is negative 11, so when we add 11 over, we get 12. And so that's going to leave us 2 times the square root of 2x minus 12 plus 2x, so it's minus 2x over. So now we have 12 minus x, because when we minus 2x, we get negative 1x. And that's equal to 2 times the square root of 2x minus 12. Well, now we can square both sides as long as we remember to square the 2 also. We have 144 minus 24x plus x squared is equal to 4 times 2x minus 12. Well, let's distribute the 4 through. And that'll be equal to now 8x minus 48. Let's minus the 8x over and add 48. So we need to add 48 and we need to minus an 8x. We get x squared. I'm going to put the x squared first. Minus 32x. And then plus, let's see, that's 12. That's going to be 192 is equal to 0. Now we need factors of 192 that add up to negative 32. We have x minus 24 and x minus 8 is equal to 0. So x equals 24 or x equals 8. Now in this example we squared both sides, which could really cause some problems. So we must plug in the values to the original equation to see if they work. Let me erase this so we can plug it back into the original. And our first answer is 24. So we plug in 24. We have square root of 25, that's 24 plus 1, is equal to 1 plus the square root of 2 times 24 is 48 minus 12. So we have 5 is equal to 1 plus, let's see, 48 minus 12 is 36. So we have square root of 36. 5 is equal to 1 plus 6. See, if this would have been a minus 6, it'd be 1 minus 5, and then when you square both sides, it'd both be 25, so it'd be true. But this is a false statement. 5 does not equal 7. 24 is an extraneous solution. It does not work. Let's try 8. We have the square root of 9 is equal to 1 plus the square root of 16 minus 12. 3 is equal to 1 plus the square root of 4. So 3 is equal to 1 plus 2, and we have a solution. We have a true statement here. 8 is a good answer. Solve radical equations. Let's isolate the radical by minusing 6 over. We have 2x minus 6. And of course we're going to square both sides. When we isolate the radical, we get 4x squared minus 24x plus 36 is equal to 20x plus 36. We need to get one side to be 0, so let's minus 20 over. We get minus 44x, and then when we minus 36, both of the 36 go away. So we factor out a 4x and we get x minus 11 equals 0. So x equals 0 or x equals 11. Let's test 0 because we squared both sides. 2 times 0 is 0 equals 6 plus the square root of, well, when we plug 0 in here, this part goes to 0. We have 36. So 0 is not equal to 12. We relied on this to be a negative, and that can't happen. But you know, when you square those negatives, they go to positives. So when you square both sides, it really causes some problems. So 0 is a bad solution. Let's try 11. We have 22 equals 6 plus the square root of, see, 20 times 11 is 220 plus 36. 22 is equal to 6 plus the square root of 256. 22 is equal to 6 plus, let's see, the square root of 256 is 16. And we have 22 is equal to 22. That is a good answer. 11 is a good answer.